Alright, welcome everybody. This is video 1 of 2 for today. We are going to be talking about isosceles triangle theorems. That should say theorems. Alright, so moving on immediately. Let us see. Here are the parts of an isosceles triangle. Nothing here should be new to you, but it's a good place to start. Okay? An isosceles triangle, remember, has at least 2 congruent sides. It can have 3, but we normally call that an equilateral triangle. Just remember, at least 2 congruent sides. Okay? If an isosceles triangle has exactly 2 congruent sides, then these things are true. The 2 congruent sides are called legs. Okay? The non-congruent side is called the base. We've talked about that. Okay. The 2 adjacent angles to the base are called base angles. And let me show you the picture. It's just easier to explain that way. Okay. We have. Okay. Sorry. Okay. We have this picture here. We've got the 2 legs. There's one leg. There's one leg. The 2 angles adjacent to the base are called the base angles. Here's the base right over here. So the angles adjacent, that's this one here and this one here. Those are called our base angles. Okay? They are the ones on either side of the base. Should not be too hard to remember. The vertex angle is the one that's different at the top up here. Okay? And that is basically everything you need to know about the parts of an isosceles triangle so that we can get on with our lesson. I'm going to try to do this quickly today. Okay, theorem 4.7 on your cheat sheet is called the base angles theorem. Okay, you will see it abbreviated BAT for short. That simply says that if 2 sides of a triangle are congruent, here's one side right here congruent, here's another side right here congruent. If those are congruent, then the angles opposite them, and you can see those with these dotted lines, this angle right here is opposite this side AC. And angle C over here is opposite the side AB. Okay? The theorem says that if 2 sides of a triangle are congruent, the angles opposite them are also congruent. So you know that if AB equals AC, then the measure of angle B equals the measure of angle C. Okay? Another way of saying that is that if the line segments are congruent, then the angles are congruent. Okay? And remember, you remember what corollary means? We have something that follows from the base angles theorem. If the base angles theorem is true, which we know it is, then we have corollary 1, which is also going to be true. And that says that if a triangle is equilateral, 1, 2, 3 equal sides, then it is also equiangular. All of the angles are going to be the same. Okay? And you can do that just by applying the base angles theorem twice. Okay, so that's something we need to keep in mind. Okay, corollary number 2. Every angle of an equilateral triangle measures 60 degrees. That should be pretty obvious. If you have 3 angles that are all the same, add up to 180 degrees, divide that by 3, you're going to have that every angle in an equilateral triangle, is equal to 60 degrees. Okay? This one right here, I do not believe, is on your cheat sheet. So you might want to just draw it in there right now, because when you do go to take your quizzes and tests, it's a good idea to know all of these. Got it? Okay. Let's go on. Let's do some math with this. Okay. Solve for the measurements of the angles x and y. Okay, we are going to immediately use our base angles theorem, which remember says that if these 2 sides are the same, then the 2 angles opposite them are also the same. So you immediately know this one's 35, x over here must be 35. So let me get a permanent pen instead of my magic pen. Okay, I'm going to go with green today. Okay, we've got x has to equal 35 degrees. Okay. And then it's pretty obvious that y is going to equal 180 minus 35 minus 35. Because your other 2 angles are 35 and 35. So you subtract those from 180. You get 180 minus 70. Y must equal 110. Okay, simple enough, right? Moving on. Actually, I wanted to point out one thing. If at any point you feel like I am going too fast, you can pause, you can rewind, you can try to work out some of these things on your own. Video allows you to be the master of what you're doing. You can make me back up and say the same thing 47 times, and I won't sound like I'm getting irritated. Okay, let's go on. Solve for x and y. Another one just like that. Okay? Got these two angles you know are the same. That makes the angles opposite them congruent. Okay? So y and 72 must be the same, and I will leave this one for you to finish solving because it's not that hard. Okay. What are the measurements of the base angles? Well, you've got these two sides here. Making these two sides the legs, making the, I apologize, making the other side that is not yet accounted for right here, this has to be the base. If this is the base, then you know that the two angles right next to it, this one here and this one here, must be congruent to each other by the base angles theorem. Okay? So you know that those two plus this 70-degree guy has to equal 180. So 180 is equal to 70 plus 2 times x, because I know they are both the same, so I can just call them both x. Okay, 2x plus 70 equals 180. Take away 70. You get that 110 is equal to 2x, or x is equal to 55. Easy squeezy lemon peasy, or something like that. One angle of an isosceles triangle is 38 degrees. What is the possible measurement for the other angles? This is a very confusing question. I left it in here on purpose because I want you guys to get in the habit, when you see a question like this, draw diagrams. They are your friends. Okay? We know that we have isosceles triangles. So let me draw one possibility that this could be. Okay? First of all, I'm going to draw my my congruent line segments there. So you know that the base is the one at the bottom. Okay? And then I'm going to pick which angle I want the 38 degrees to be. I do have that freedom because they did not specify. So let me call this 38. If that was 38, then I know this other one right here is also 38. And so I have 180 minus 38 minus 38 has to be my other angle. So 180 minus 6076 is going to equal 104. Okay? And so I've got that right there. So my answer right here is D. But wait, there's more. What happens if I drew the same diagram, but instead of making 38 one of the equal angles at the bottom, one of the base angles, what if I made this 38 up here? Okay? Then I know that these two here have to be equal to each other. I'll call them x again, because I'm not really imaginative. Okay? So I've got 38 plus 2x is going to equal 180. Okay? And then I just solve for x, minus 38, minus 38. 142 is equal to 2x, making x 71. So I know that each of these are 71. And so my answer is A. Clearly, this was not a well-worded question, but I liked it enough to leave it in here because I wanted you guys to realize that you can make diagrams, and you always have to wonder to yourself, is there more than one way to make the same diagram so that I would get a different answer? These are some of the thoughts you need to start thinking. Okay, we're going to move on. Okay, theorem 4.8, the converse of the base angles theorem. Remember when we were doing our transversals, we had all those converse rules? Remember, the converse means we're just saying it in reverse. So the base angles theorem said if I had two sides, that are the same, namely if I had this one right here and this one right here, then these guys are gonna be equal. The converse says exactly the same thing, but in reverse. That is, it starts that if I have these two angles the same, then the lines opposite them are congruent. Okay? If angle B is congruent to angle C, then AB is equal to AC, as you can see in the diagram. Okay? Not a lot different, but it does say a slightly different thing. That's why we need two different theorems to say it. Corollary number 1 to that says that if a triangle is equiangular, all the angles are the same, then that means it's going to be equilateral. Okay? Exactly the opposite of one of our corollaries from the last one. Nothing terribly difficult with that. If you want to think about it again, go back to rewind the video about 30-40 seconds, and you can listen to all of that again. We're going to go and do some math with that now. Okay? What is the measurement of FD? Well, the only thing they tell me is that we have an equilateral triangle here. Just give me a second. I'm going to change to basic so this stops coming up. I don't think it will affect all that much, and hopefully the recording didn't stop. Let me just check my time real quick. 11 minutes. Okay, we're doing all right. All right, so I've got the measurement. I've got this picture here. It tells me that I have 3 equal angles here. Okay, and I know that I have this side right here is 4. Okay, going back to the corollary, if I have if the corollary to the converse of the base angles theorem, which we just talked about in the previous slide, if I have 3 angles that are all the same, that means that all the sides must be the same. So I don't even need to do that in temporary. I can do that for permanent here. Okay, those are all the same. So I know that if this one's 4, this one must be 4, that one must be 4, and I am done. FD, or the measurement of FD, so we would do that like this. FD equals 4. Okay, let's go. Wrong way. Classify the triangle by sides and angles. Okay, we are going to use all of the theorems and the corollaries that we have learned here, and we are going to go through these next couple slides and figure out what we actually know about each of these triangles. What we want to do first is label everything we can. We see that we have 2 angles that are the same here. Right here, right here. That should immediately tell me, hey, these guys are going to be the same. I know that one of them is 7 here, so the other one must be 7. Okay? So we have immediately an isosceles triangle that is, well, it appears to be, just based on the picture, it appears to be acute, and so we're just going to call it acute there. Okay? In theory, there is not enough information to say for certain that it is acute, because the picture could be skewed, and we could have something like that, which would make it obtuse. But there's no other information, so I'm just going to call it acute for now. Okay. This one right here, I know that I have 3 sides that are all the same. So I'm going to label these guys like this. And that should immediately tell me, hey, let's look at your corollary to the base angles theorem. If I have 3 sides that are the same, I must have 3 angles that are the same. And this becomes a real simple question. Equilateral, equiangular. And remember, you can never have one without the other in triangles. Equilateral implies equiangular. Equiangular implies equilateral. So we can use this guy, remember, biconditional, if and only if. Okay? Okay, let's go. Okay, we have this triangle here. 2 sides are clearly the same. So immediately, before I even read the question, I'm going to label this guy the same and this guy the same because of our base angles theorem. Okay, now I have an an isosceles triangle that has 2 angles the same. I have a 3, 3, 4. So I am going to call this guy isosceles. And once again, I'm going to call it acute because for it to be obtuse, this side right here would have to be a lot bigger than 4. Or at least some bigger than 4. 3, 3, and, I don't know, 5 or something. Okay, cool. Let's go. Classify the triangle by sides and angles once again. Okay, so here's where you could get tripped up. You see that you have two sides the same. You see that you have two angles the same. You might say, well, there's nothing else I can label here. Except that you need to be very careful. The equal angles, let me use my magic pen here. The equal angles here are directly opposite of the equal sides. So this one right here, up here, is directly opposite this one. That's 12. This one right here is directly opposite this guy over here. And these two sides, that one there, they need to be the same. So I can go ahead and I can label this one 12. Once I do that, I see I have equilateral, so I automatically know that I have equiangular as well. I like that question because it's easy to say, okay, that's going to be isosceles, because I see I have two angles and two sides that are the same. But you always need to be careful about that. Okay. Find the values of x and y. Okay? So, we've got a lot of information going on here. And the first thing we're going to do is just, we see a diagram, let's label everything that we know that is not already told to us. Okay? So the first thing I'm going to do is say, this is equilateral triangle here. So I know that all the angles are the same as well. Y, so that's got to be y and y. Okay? Now I know that I have x over here, and I have an equilateral triangle. Okay? So the base angles need to be the same. This one's x, so this one over here has to also be x. Now the only thing I have to find is this guy right over here. Okay? And to do that, what I'm going to say is, what do you know? This is a straight line, so this angle here and this angle here must be a linear pair. So y degrees, that's clearly not what I meant to do. Okay? We've got y degrees is equal, sorry, I forgot what I was doing. Yeah, there we go. Y plus this guy here is equal to 180. And I still got my magic pen going. I don't want that. Okay, there we go. So I know that I can find this guy by doing 180 minus y. But the problem is I don't know what y is yet, do I? Well, I really do. Look at this. All three of these angles are y. You have an equilateral triangle, equiangular triangle. We know by the second corollary to the base angles theorem that if you have an equilateral triangle, all of the sides, or all of the angles must be 60 degrees. So you know that y equals 60. Once you know that y equals 60, I can just put that in here. Change colors to try to not make this so confusing. Y equals 60 here. Okay? So this one here has to be 180 minus 60, otherwise known as 120. Okay? And once I know that that's 120, I can put it in right there. 120. And that will allow me to find what x is, because 120 plus x has to equal 180. So I know that 2x is going to equal 60. So x equals 30. I'm sure the next couple slides say exactly what we just did, so we can probably skip them. 120, x equals 30, yeah. Cool, we rock. Okay, and let's finish up real quick. What is the value of y? Well, I want you guys to think about something. You immediately know that these lines imply that these guys are the same. Okay? You also have y as an exterior angle. forget this. Forget about this guy right here. Pretend it's not there. Okay? Just pretend this goes on forever, and you've got this triangle here, and just this straight line that goes on. So this guy, by your exterior angles theorem from last time, that guy right there has to be equal to the sum of the other two angles. Okay? So y is going to equal 70 plus x. Well, all we need to do is figure out what x is. X is here, x is here. Okay? So if we have these two guys, let's find out quickly what they are. X plus 1 plus 70 has to equal 180 degrees, because those are the three angles making up a triangle. So minus 70, 110 is equal to 2x. So x must equal 55. So let's label that 55. Now, by the exterior angles theorem, y here has to be the sum of 55 and 70. So y equals 55 plus 70 equals 125. All right. If anybody is confused by all the theorems going around, you need to bring out your cheat sheet. You need to start looking through them, highlight the ones we've gone over in this chapter, and I would strongly suggest making index cards so that you can remember what they are. Even though you'll have your cheat sheet on the test, being able to immediately recall the information and what each theorem says will help you immensely. Okay? Let's see. Let's see what's left in this. Okay, so there's just two more, and I'm going to do those quickly. I am sorry. Not. If anybody's laughing at me right now, I understand entirely. Oh, come on. My smartboard is not all that well aligned right now. Okay, so we've got all this. We're moving on to this one. What's the value of x? Well, let's look right over here. We've got x here. These two lines here tell us that the opposite angles, that one and that one, have to be the same. So I can go ahead and label this one x. So I know that x is there, and we can kind of do the same thing over here. These two are the same, so this and this have to be the same. Okay, so I can immediately label that one 50. That allows me to know what this one is here. That's 180 minus 50 minus 50. So we know that if these two add up to 100 here, this one and this one are 100. This one has to be 80, because that's all that's left. I know that that one is 80 degrees. Okay? And let's see, does that help us answer our question, what's the value of x? Well, we need to find one other piece of information, and that's that this one right here, these two right here, make a linear pair. So if this one's 50, this one has to be 180 minus 50, otherwise known as 130. They have to add up to 180. And if this is 130, then these two here are the same, so we can write this little equation here. 130 plus 2x equals 180. Take away 130 from both sides. We get that x equals 25. And we can go on to our last question. Okay, solve for x in the diagram. Let's see what happens here. We've got these guys are equal, so the first thing, before you think about anything else, just make sure that you mark their opposite sides as congruent. Okay? So I'm going to say that and that are the same. So once you know that 28 is going to equal 3x minus 17, because those lengths are the same. Just solve for x, and we are home free. got 30, 45 equals 3x, so x equals 15. I'm done. That's it for that video, and I will see how our time did. Great. All right, we're good.